Yeah. Where am I? Okay, so what we're going to be covering, I would say that for the most part, in terms of the code that we need to learn for the rest of the semester, is mostly done. Oh, not plugged in. Yeah, the code that we need to learn is mostly finished. The only thing we'll have left really is theory. One second. We'll have some theory that we need to cover.
Wow, what's that?
Hold on. Let me see if this is still recording. Okay.
This is a computer class?
A computer class?
Like typing, you know, it's like.
Oh.
Or it's like listening.
This one is listen. Listen and discussion, yeah. What's that? I am currently recording, yes. All right, cool. So yeah, what we've been looking at for the most part so far since the course started or the semester started is web development technologies, specifically REST, the REST API technology, right? And I've been showing you how you can use REST to send data from a device to a server and how to get back information from a server back to the device. And we know that that's typically done in a client and server relationship where the client have to talk to the server and the server respond. It's not a case where the server can initiate communication, right? Depending on the scenario, you may find that that may not be efficient or desired for your project. Very much depending on the project, the scope of the project. So I'm going to be showing you other technologies and other protocols that you can use to see if it would fit your needs a little bit better. So I'm going to be going through explanations, advantages and disadvantages of other technologies that exist in this space. All right. So the four technologies I'm going to be covering are REST. You guys know about REST already. MQTT, WebSockets, and SOAP. We're not really going to be talking too much about SOAP, to be honest. Yeah, name SOAP. We're not going to be talking about SOAP all that much, to be honest, though. Like, I just mostly have it in the slides to say that I covered it. And I'll give you information and so you can read it upon it yourself, but it's not very important because we would not be using SOAP in a project, an embedded project. It's not a good protocol to use. And you'll see why in a second. Is that a hockey stick? Cool. So yeah. So we talk about REST. We talk about the things that we know about REST already. So it's what you guys are familiar with. It's a request and response model. And the entire thing happens over the HTTP protocol, the Hypertext Transfer Protocol. Yeah. The first point I have there, it's stateless. So when I say stateless, what I mean is just because the client sends a message over to the server, it is not expected that the server must know about the last message that the client sent to the server. So like if you send that message at 12 o'clock and you send another one at 12:01, the server does not know that it sent one at 12 o'clock. All it knows is that it got a message. It is up to the client to fill in the blanks where necessary. So if it's a case where you have your microcontroller and it's supposed to take some readings and send these readings to the server will not automatically know where these readings are coming from. If the server is supposed to know where the readings are coming from, the client have to tell it. Yeah? So the only thing that the server knows is what the client tells it. So that's why it's considered stateless. It doesn't know anything about where the message coming from unless you specifically tell it, and it doesn't know anything about the previous messages, right? It only knows about this current message where you send me now, and you don't know nothing else, right? And we looked at how we could basically establish different types of communication, whether we're supposed to be retrieving information, creating, updating, or deleting. And it uses JSON to send these messages, or the language that it uses to communicate these messages. A good thing about JSON is, in my opinion, it's human readable. And it's predictable. It's something that you can write relatively easily. And it's easy to understand. Yeah? And we use that to map out different CRUD responses. And remember we talked about CRUD being create, retrieve, update, and delete. Yeah? So those things, we use the conventions laid out for us by the HTTP or the REST framework to create these different functions. Yeah? And in the context of IoT, it's useful because you might have a case where you only want to send data periodically, right? It's not a case where maybe you don't need real-time data. Or if you do need real-time data, it doesn't need to be as soon as it measures it, the server knows it immediately. If it's a case where you need to be able to send data every 2 seconds, every 5 seconds, then it's good for that. Where one of the problems may come in, though, is the amount of data you'll be sending. So if it's a case where you are sending a little bit of data, suppose you're taking one sensor reading, a temperature reading, and that comes in the form of a JSON that just says temp and then a number, right? That's a relatively small packet of data to send. The problem is, for REST, the amount of data that you have to send in an HTTP request is a whole lot more than just the message that you're sending. Think of it like you're sending an email to a colleague in a formal setting. You can't just open up Gmail and just type, "Where's class today?" You have to say, "Dear so-and-so, I hope this email finds you well. I'm just emailing to tell you that I am in need of some assistance and I'd like to know where class is going to be held today." And then you say, "Regards, Philip Logan," right? So you have to type out a whole heap of foolishness first. I shouldn't say foolishness, but a whole lot of overhead stuff first before you can get to the reason why you're sending this message. That's how REST is. REST, you have to send a lot of headers and a lot of setup. You have to specify what type of message you're sending, whether it be post, get, update, or delete. Then you have to specify which route it's going to. You have to specify the version of HTTP. You have to specify the content type, the content length, and then you can put the message. Yeah? So there's a lot of information that you have to put in your message for it to be recognized as a valid HTTP request before it is sent, and then you can put the message where you want, right? So depending on the situation, that might be a lot of overhead. You find that if you have a system that you're building that really only needs to, let's say for instance, you have a scenario where you have a microcontroller connected to a relay, and that relay is supposed to control whether an AC turn on. In a case like that, if that's the only thing you're supposed to do, then what you'd have to do is write code for the ESP to make a request, a GET request to the server, to ask it, "Should I turn on the AC?" And the server going to say no. Then you're going to send a message again, "Should I turn on the AC?" You're going to say no. And you just have to keep sending that message over and over and over. And it may not ever tell you to turn on until, a month down the line or maybe a year down the line or whatever. Whenever you're going to turn on, it's supposed to turn on. You are constantly sending all of that information just to get back a no every single time. You are sending a lot, seemingly a lot of data, or relatively a lot of data, just to find out that you're not supposed to do anything. That's a lot of overhead. If it was a case where you technically are being charged. Like if that was a case where you were using GSM and you were reliant on mobile data, you'd be charged, or you'd be expending data on those messages that tell you that you don't need to do anything. Yeah? So even though you'd be sitting down asking and getting back a no every time, eventually the data would done. Yeah? It would take a long time for it to finish because it's just text. But still, you'd be using up data just to hear that you're not supposed to do anything. Right? So that could technically be a problem depending on the situation. Right? But if it's a case where you're not on data, you're on Wi-Fi, it might be okay because you don't really need to be concerned about the data that you're sending. Especially if it's not that much data. It is a lot of data, but only in comparison to the other technologies we're going to be looking at. Right? So yeah, it can be seen as wasteful depending on the situation. But that's REST. And I'll tell you the reason why I went with REST for this course. I'll give you 2 reasons. The practical reason and the actual reason. Let's start with the practical reason first. So the practical reason is REST is not only useful for IoT. IoT is completely secondary or tertiary for REST, right? With REST, you have the skills needed to be able to do web development in general. You can do app development with it, you can do web development, you can build your websites, communicate with a server, build a mobile app, communicate with a server, yeah? And the IoT is only secondary. So with that information, you can go into a web company and apply this knowledge, and it would help you to get the start that you'd need, so you wouldn't have to learn from scratch. Yeah, that's the practical reason. The actual reason is that's all I knew when I just started teaching this course. Yeah, so it's just luck that it eventually became something that was relevant for this. Yeah, and honestly, to be honest, I'm like, looking back, I don't think I would change. Even though I know other things now, I would not change teaching REST for this course. It is good that you guys know this, so it's important for me to teach you guys these things and make it so that you know it. That being the other technologies, MQTT and WebSockets, so that you can go and do your own research and figure out how to do it yourself. And knowing REST first, since in my opinion it's the easiest to implement, I would say that it gives you a good foundation. It teaches you about the technologies so that you can build on the information that you have already to go further and learn the other things. It makes it a little bit easier to learn the other ones. Yeah? So that's REST. Next one I want to look at, did I go through these already? Yeah. Oh, actually, I need to talk more about the strengths of REST. I talked about the weaknesses more or less already, but the strengths, so a lot of the things that you get from using REST, first point being there's a huge ecosystem. You have a lot of tools that are ready built for this type of development, and it makes it easier to get into it because there's a lot of ways that you can test your code, write your code, see that how it works without actually having to build a whole system. Like your Postman, you have a lot of frameworks that are built around the REST technology, like Fast API and Flask. There's a lot of documentation on it as well. Yeah, and the platforms that are available to you, for example, your Rendo, AWS and Azure. I think I would have probably talked about Rendo in class before, maybe, or I would have given you an API that's hosted by Rendo. Yeah. So there are a lot of platforms that are geared towards REST technologies. So it makes it easier for you to get off of the ground or get out of your laptop or get out of a testing environment for you to actually deploy your applications. Not to say that there aren't platforms that are readily available for the other technologies, but these ones are pretty common. Rendo, AWS, and Azure. They're pretty common for REST technologies. Right? So yeah. I kind of don't want to the MQTT just yet. I want to the WebSockets first because I feel like it made more sense to explain WebSockets because there was a time where I thought that the two of them were the same, but I'm realizing now that they're not the same. But WebSocket is more manual than MQTT, so I want to explain the more inconvenient one first to show you how convenient the MQTT is. So WebSockets is something that I think would have come up a few times in conversation in class, where when we compare it to REST, REST, you as the client have to say something to the server for the server to tell you back something, right? So you only get communication in one direction. It's technically two directions, but it has to be initiated by the client, right? That's REST. For WebSockets, it's bidirectional. Anybody can tell anybody anything whenever, right? Going back to the email scenario I said a while ago where you have to greet the person, ask them if they're all right, and then you tell them what's up. For WebSockets, you don't need to do that. It's like you're sending a message over WhatsApp. All you do, you just send your message. You send it whenever. And I can send it to you or you can send it to me. If I have any reason to talk to you, I just talk to you. If you have reason to talk to me, you just talk to me. Another difference is, you know how when we're writing our code in ESP, for ESP, and you have to do a HTTP begin to establish a connection to the server, and only after you establish a connection to the server, then you can send your message, and then you have to close the connection. For WebSockets, it's a persistent connection. You start up a connection one time, and then you just talk when you want to talk. Yeah? And then when you finish, then you close the connection. But when I say when you finish, I don't mean after you send your message. I just mean if it's a case where like the ESP needs to turn off. Yeah. So you close the connection when the device disconnects from the network, right? So it's just a case where you're able to, anybody can talk and say anything they want to anybody. And it's a direct connection between the client and the server. So in that case, the amount of data that you're transmitting between the client and the server is a whole lot less than REST. There is a similar REST-related component when you're doing WebSockets, but that only comes in the form of starting up the connection. So if you want to establish a connection to a WebSocket server, you have to send an HTTP request to it first, just to let it know that you exist and you want to start a connection. When you start that connection, you just start talk. If I wanted something to you, I just say it. If you want something to me, I just say it. Yeah? So the overhead, the amount of data that you have to send in order to get your message across is a whole lot less than WebSockets. And those are some of the good things about WebSockets. But in the case of IoT, you may find that yes, it is good for real-time connection or real-time communication, because as soon as you have something to say, you can just say it. But one issue may come in the form of allocating memory. Keeping a connection up and persistent between a client and the server, it will take a certain amount of memory, right? More memory than it would take for you to send a message and then close the connection with REST. And this is only a particular problem because your microcontroller may not have several gigs of memory like your laptop or your phone or your computer. It's something that you need to watch out for because of the limited amount of memory. So having to keep a connection up and running all the time, that takes a certain amount of memory, and it's not ideal for an ESP or your microcontroller. Another thing is being able to reestablish a connection after the network connection has dropped, if it drops, is something that you have to do manually. It's not a case where if your Wi-Fi goes down, as soon as Wi-Fi comes back, it's going to automatically bring up back the connection. It's not going to do that. You have to manually implement that, right? Yeah. It's still a problem with REST, you know. But at least it's a case where with REST, you can write some code to say, if there's no Wi-Fi, then don't do nothing. With WebSockets, yeah, exactly. With WebSockets, it may be an entirely different type of code that you have to write, where whenever you're writing some code for it, if you have to be able to detect if the connection is still up. And if it is not up, then you try to reconnect. And when it's reconnect, then you can send your message, right? And in a case where you're trying to deploy several microcontrollers to be communicating with one server, you find that you're going to have to establish or manage a whole lot of connections, a lot of persistent connections between the different microcontrollers and the servers. And that can get complicated. Having to manage them all in one place is going to be difficult, or it's going to be resource intensive for the server, yeah? Because each connection is peer-to-peer or direct from client to server. Yeah? So that's with WebSockets. Yeah, okay. Actually, hold on. I think I have some diagrams. Let me see if I can pull those up. These diagrams. This diagram, this one should be relatively straightforward. I think the way I have the arrows are kind of misleading. The arrow should actually just start from this edge to show that it is this entity communicating with that entity. So don't look at the specific box that it's pointing at. So yeah, in the case of REST, you have your ESP that is connected to its sensors and the Wi-Fi. It reads the data from the sensor, builds the JSON, and then it sends a message. And then after it does that, it sends a request, right? The server side now will have the route handler that comes in the form of your function that expects a particular post request on a specific route. Then it goes through validation. It stores it in the database if it's supposed to, and then it sends a response, right? So this talk first, this does something, and then this talk back. Yeah? For WebSockets, let me see, where's my WebSockets one? Right, so for WebSockets, you have two parts to it. The first part is the initial connection, the handshake, where the client and the server must make themselves known to each other first. And that's done in an HTTP request, right? Once that's done and they know about each other, then it don't matter what happens next. They can just start talking to each other in any direction. So this says, sending a reading, it received it. It sent a next reading, it received it. This send a command back, it receive it. This send a message, this receive it. So anybody can talk to whoever at any time. So it's peer-to-peer, it's not client-server. Make sense? So there's no need for any polling in a case like this. Whoever wants to talk, them just talk. Okay. Right. So MQTT now, message queuing telemetry transport. That one, it's similar to both REST and HTTP, REST and WebSockets. Yeah, and I'll tell you the similarities. With MQTT, you're still only sending a message. It's not a persistent connection. So you establish a connection, you send your message, and then you close the connection. But it can still be bidirectional. Anybody can talk to anybody. And the reason for that is because the way it is handled is when you're sending a message, you don't send a message to a particular node or a particular entity on the network. You send your message like on a bulletin board. So you have a bulletin board, and I want to make it known that I am sending this temperature to the server. But you're not sending it to the server, you know. You're sending the temperature to whoever cares. So you go to a bulletin board, and the bulletin board says temperature readings. I'm just going to put my temperature reading on this bulletin board, and whoever wants to see it, them see it. So it's a case where you need to establish topics, and when you establish your topics, if it's a case where you need to be able to get that information based on that topic, then you subscribe to that topic, right? So what that means is, a topic is defined called temperature, and then the server needs to subscribe to that topic. When the server subscribes to that topic, anytime one of the microcontrollers put a message on that bulletin board about a temperature, the bulletin board or whoever is managing the bulletin board will know that the server is supposed to get that message because the server is interested in getting temperature-related topic messages, right? And the same thing goes for if the server needs to send information to a microcontroller. Only the microcontrollers that are interested in knowing about certain information will subscribe to getting that information. So if the server needs to send a message to a microcontroller that it's supposed to turn on a light, it will find the light bulletin board and post a message to the light bulletin board. And only the microcontrollers that are subscribed to that topic will get that message, right? So with that, you find that managing resources, managing who gets what message is a little bit easier because the server itself doesn't need to know who's supposed to get the message. There's another entirely different entity that handles that. Yeah? So there's another entity called the broker that needs to be involved in this. It's not just client and server. There's, I don't even want to call it client and server. It is publisher and subscriber, and in between the two of them is the broker. Yeah? So the server can be a publisher and it can be a subscriber. The microcontroller can be a publisher and also a subscriber. And then who gets what message is dependent on the topics that are laid out in the broker. Right? So you can think of the broker as the bulletin board where all the messages get relayed to. All the messages will be sent to the broker, and the broker is what determines who gets what message. Right? So it's similar to WebSockets in that you can get bidirectional communication. The microcontroller can send a message and the server will get it, and the server can send a message and the microcontroller will get it without having to make a request and expect back a response. Yeah? But it's similar to REST in that you're still establishing a connection, sending a message, and then closing the connection. But it may not come in the form of starting up a connection, sending a message, and closing a message when you're actually implementing it. Because MQTT actually was built for IoT, and it handles a lot of that stuff for you in the behind the scenes in the framework. Another benefit that you get, it doesn't have as much overhead as REST. So like when I was saying you have to specify all of the different headers and information about the HTTP request in order to send a message, MQTT doesn't have all of that. It still has some overhead, but it's significantly smaller than with a HTTP message or a REST message, right? What was the other thing? The other thing was, the quality of service levels. Quality of service is a concept in networking that helps to manage traffic as it is sent from one entity to another. So it does stuff like being able to manage congestion, latency, or some of the other things. Looked up a while ago. Where is it? All right, hold on. Oh, see it here. So it does things to allow the managing of a particular network where you want to manage congestion, latency, jitter, and packet loss. So QoS helps to assist with that. And you get access to certain QoS rules or quality of service rules when you use MQTT, as opposed to when you're using WebSockets and REST, where everything is just treated as generic traffic. There's no priority on any particular type of data that's being sent over the network when you're using REST and WebSockets. But MQTT, you can define what's supposed to be prioritized. Yeah? You can think of it in a case where, like, I want to think that when you're streaming, like your shows, yeah, Netflix or whatever, there are certain rules put in place to make it so that this type of traffic is prioritized over other types of traffic, because when you're streaming a show, you don't want it to buffer. You don't want frames from the show to come out of order. You want to make sure that everything is flowing from start to end. So there are certain quality of service features that are put in place to make sure that the network traffic is handled in a predictable and desirable way, right? I'm not sure if you have to manually, if you do have to manually do it, I think it's just configuration, it's not code. Yeah? So you get that benefit when you use MQTT. You get certain, your data is prioritized depending on the type of data that you're sending. Yeah? Mm-hmm.
Is what is priority. So when I watch a movie
Mm-hmm.
and I use a phone as the last thing,
Mm-hmm.
that is what is priority on the network.
You're telling me?
No, man.
Oh. I'm not sure exactly how it would work in that case. I would have to get back to you and tell you. But yeah. So yeah, that's MQTT. And let me see. It's low bandwidth, like I told you. It allows you to send your messages without a whole lot of overhead. It is bidirectional because anybody can be a publisher, anybody can be a subscriber. So messages are bidirectional. It scales really well because with the problem that you got with WebSockets, where you have to be able to manage a connection between all of the different ESPs and one server, the role of managing connections and directing messages is now offloaded onto the broker, where it is another machine or another entity that sits in between the messages that or the entities that are sending messages to each other. So the broker is the one that has to set up or make it so that anybody who needs to read a message is able to get that message. And because it's a third entity that's sitting in between the entities, setting up a connection whenever a new device is introduced is handled almost automatically. It's not a case where the server needs to know that there's a new ESP connected. It doesn't need to know. All it wants to know is that anybody that posts on this particular bulletin board, only the people that are interested in getting that information need to read it. So anybody can post to it, right? So you get a new ESP you put on a network, the rest of the system doesn't need to know that it exists. All it wants to know is that this is where the bulletin board is. Any information about temperature, you post it here. Any information about humidity, you post on this one. And whoever wants to read it can read it. Yeah? Okay. Right, and like I said, it was built with IoT in mind. Right, one of the weaknesses. I mentioned all the niceness that comes with a broker, but having a broker means that you need to have another piece of software, right? So you have to have an entirely new entity that you put in your system to be able to handle these messages. It is not to say that it's difficult to get this broker, not expensive or anything like that, but it is another system that you have to be aware of. Yeah? So it adds another layer of complexity or another point of failure. And I guess some of the other stuff that we have listed here as weaknesses. They are kind of weaknesses, but in my opinion, these are things that you can sort of implement manually. For example, this one here, it says no built-in schema validation. We don't have built-in schema validation in Fast API. We had it because we implemented Pydantic. So if you have a system that you're building and you want to use MQTT, just get Pydantic and then have it so that whenever a message comes in, you validate against your model. The problem comes from when you have a REST API setup. When a message comes in, if it doesn't follow the Pydantic schema, then kind of by default, it automatically knows that it's not supposed to accept this message because it does not go in accordance with the schema. MQTT does not have that. You would have to implement that manually. So yes, you can use Pydantic to say that when a message comes in, compare it against this schema or this model and see if it's valid. But if it's not valid, you can't return a 400 HTTP response in MQTT because they don't have status codes in MQTT. It just sends a message. So it would be on you to establish whatever logic is supposed to happen in the event that you get back some data that is malformed or not structured correctly. Yeah?
So you would have to format the data basically.
Yeah, you'd have to format the data based on what you're expecting to come in.
But other than the shared format before it comes in.
Yeah, so that's with REST. It makes sure that it's formatted properly before it comes in. But with MQTT, the message already comes in. Whether you want to validate against Pydantic is up to you, and if you do, it's not going to stop it from coming in. It will come in, and then you validate it, and if it's wrong, it's just wrong.
So supposed to come in and display, or just display garbage.
Not necessarily display garbage, it depends on how you write your code. But the data will come in, and whether it's valid or not, it will still come in. Yeah? Yeah. Yeah. And it's a bit harder to debug because a lot of the tools that we have to send messages using REST or WebSockets, they don't work or they're not geared towards using MQTT. I think you can send MQTT messages in Postman, but the data that you send isn't always going to be transferred or transmitted in a way that's like human readable. There's going to be a lot of machine code or machine-like language that you're going to have to go through in order for you to debug it. Yeah. Let me see. Do I have a diagram for that one? For MQTT, right. So yeah, as I was saying, on the left side, you can consider these two to be the same entity, but I have them listed twice because the ESP itself can be a publisher and it can be a subscriber. And then you have the server on this side that can be a publisher and a subscriber, right? This in the middle is our MQTT broker that collects all the messages and directs it to whoever needs to read it. So everybody can send a message to the broker, everybody can send a message to the broker, and whoever needs to read it will read it. Yeah? It is an entirely different setup, yeah. Mm-hmm. So no, it doesn't have to be on a different device. It can be on the same device as the server, but when you're sending your messages from the ESP, you don't send it to your Fast API server. You send it to the broker, and then the broker will determine whether or not the server must get the message. And then the same thing when you're sending a message from the server to the ESP, the message has to go to the broker, and then the broker is the one that has to determine whether or not the ESP is going to see it. Right. Depending on if this ESP is subscribed to this topic. So if you have different ESPs deployed in the field, and this one is supposed to be turning on a light, and this one's supposed to turn on the AC, and this one's supposed to turn on the washing machine, if the server sends a message and posts it on the light bulletin board, only the light ESP will react to it. Yeah, because only the light ESP subscribed to that topic. Similar to like on YouTube, you only get well, that's not true. But you get notifications for when a particular person posts a video because you're subscribed to them. You don't get notifications for every single upload on YouTube, right? Mm-hmm. So that's that. And then like I was talking about the last one, SOAP, that I personally don't know a whole lot about. I have used it before, But all I know, it's very similar to REST, but you don't use JSON. You use XML. Have I showed you XML before? Haven't shown you XML. Let me show you what XML looks like. XML. No, that is. So this is an example of what XML could look like. It looked like HTML.
XML or
That is
extensive.
not what I wanted. Hold on. This, yeah. So you can send messages similar to JSON, where you have your curly brackets and you specify temperature, humidity, and whatever, and you have a colon and then the message itself. In this case, you specify information not in a similar way, but you still have all the necessary keys, like you have this is a note object, and then you have your to, you have the from, the heading, and the body. But the way it's written is different. You write it like HTML. You write in your tags. Yeah?
The second statement with the slash and you close it.
That's the closing, yeah, right. So this is a tag, this is an opening tag, and this is the closing tag. So any text that you put in between it will be considered the to information. And then this is the from, because it's in between the opening and closing tags. Yeah? And everything here is written in a note, because you have the opening note tag and the closing note tag. Yeah? So it's a whole lot heavier than JSON, because you have a whole lot more data to type out. Yeah? And I think there's a whole lot more, overhead as well. But like I said, I don't really know too much about SOAP because I've only ever used it and I've really studied it. And you find that, modern IoT platforms have moved away from SOAP. SOAP is used mostly in the enterprise environment at the moment. So like your big companies, that's the first time I ever used it. I was working at Digicel. And we're communicating between two different applications, and I had to send my messages over in SOAP using XML. And similar to how when you're writing your code in Python, you have to make sure that the messages that you're sending conform to a particular standard using Pydantic, which is something you have to implement. For SOAP, you still have that, but I believe it is mandatory, or else you can't send anything at all. You have to conform to a particular contract that says if you're sending a message on a SOAP server, it has to have these tags, it has to have this value, it has to have this, this, and that. And if you don't conform to this, you can't send anything at all. Yeah, it's very strict, which is probably why they use it in enterprise scenarios. Because you want to make sure that the data that you're sending in your big company is exactly what them say it's supposed to send. Right? So like this is an example of the amount of overhead that you would have when you're sending JSON or in REST. It may be like 30 bytes of overhead compared to MQTT's 2 bytes of overhead. In SOAP, over 500 bytes of overhead. So that 500 bytes is going to be data that is not relevant to the message that you're actually sending. It's just information that you have to send just for it to be considered valid XML or SOAP. Right? Yes, a whole lot of fluff. Yeah? Not to say that it is useless, you know. It's necessary for you to be able to send the message, but it's not relevant to the message that you're actually sending. Yeah? All right. So yeah, it's far too heavy for you to consider for IoT or using ESP. It's very much overkill. So that's why I said I wasn't really going to spend too much time on this, because it's not something I would ever expect anybody to use for any reason in IoT. Like I cannot think of a reason where SOAP would be beneficial over any of the other three. The other three, REST, WebSockets, and MQTT, they have their place in IoT. So it very much depends on your situation why you choose it. But SOAP, no, you don't need to know that. You don't need to know that. So yeah, I have like a summary of the type of information that you need to know about each one of the different ones when you're making a decision as to which one you want to choose. The type of communication that you're doing in REST is request and response, meaning somebody has to talk first before somebody else can respond, and it's always the client who talk first. For MQTT, it is publish and describe. Anybody can be a publisher, anybody can be a subscriber, so communication is bidirectional. WebSockets is full duplex. Anybody can talk immediately. So you talk directly to the person that you're talking to and then talk back to you whenever they feel like. And then SOAP is also request and response like REST. SOAP and REST are very similar. It's just that SOAP is the heavy version or the old version of REST, in my opinion. Yeah. So yeah, all of these things that you need to consider when you're choosing what what framework or what protocol works best for you in your scenario. Yeah.
What is a domain password? Is that the login password?
Domain password? What's the scenario? What's the context?
Set a BLA or your school. What is it?
Oh. When you're signing into one of the machines, like for example on the lab, when they're connected to MIT's network, it would be like your intranet password. You have an account on the network. So you have like a network username and a network password that's specific to the network. It might be. Yeah, it might be. Okay. Whoops. Really? 1 second. Yeah. So yeah, you have different ways you can come to which particular platform or framework you want to use. You ask yourself these questions. If you want to know which protocol to choose, you can ask yourself, how constrained is your device? If you have limited RAM, then you may not want to go with WebSockets. But if you're using like something like a Pi or something similar to a Pi where you have gigs of data, maybe you could choose WebSockets. If you want to know, or rather, if the question is who initiates communication, whether it can be bidirectional or it has to be initiated by a particular entity first. If it's bidirectional, you can go with MQTT or WebSockets. But if it's just a case where only one person needs to talk and somebody can respond, then you go with REST. Yeah? How the data flows, how often does the data flow? If it's periodic, then you can use REST for that. But if it's something that you need to be immediate, real-time, instantaneous, then you use, I think MQTT and WebSockets would be good for that. I know WebSockets for sure, because the message gets delivered as soon as you send it. MQTT, I wasn't sure before, but yeah. MQTT should be able to be more or less immediate. And then how many devices? If it's a handful of devices, then yeah, REST should be fine for that. But if it's going to be like thousands of devices, hundreds and thousands of devices, you may want to use a platform that handles scaling large amounts of data or large amounts of connections a little bit more easily. And you may want to use MQTT for that as opposed to WebSockets. Yeah. Let me see. Yeah, some more questions. You can go through this on your own time. I'll post this on, what's it called? Yeah, on VLE. So yeah, the main thing to take away from this, it is not to say that REST is bad for any reason at all. It's useful in the IoT space and it's very much useful outside of IoT. But depending on where you want to go with your career or what you want to do with embedded systems or your IoT, MQTT might be something that is worth looking into, understanding a little bit better. Unfortunately, I'm not going to be able to do a whole setup on it. And maybe I can try to do something, but it's the level of complexity would make it so that when I'm showing you, I could show you how to do it, but I wouldn't be able to walk you through setting it up yourself because you have to get a lot of different things working before you can actually get it running. Come again? A lot of different parts. And I'm trying to remember, I've used it a couple times before, MQTT. And I don't know if you guys are familiar with Docker, D-O-C-K-E-R, Docker. No? Yeah, I think I had to get Docker working on my machine before I could use it because the way the application is set up, I don't think it's something like a Windows application that you can just download and install. Yeah. But maybe I can look into it and show it one day. WebSockets, on the other hand, would be something that I'd be able to show because WebSockets, the feature for WebSockets is built into Fast API. So it's something that we technically already have use of by using WebSockets. So I will be able to show an example of that. No, we're not doing soap. Soap can stay. Soap lucky. Yeah. Let me see if I can do up an example for you. One sec. Let me pause this. MVENV. Okay, let's see. So I have accept. Well, true. Just receive it. What do you do with it when you receive it? Is there no receive method? Alright, let me see something. WS dashboard. Sockets. WS colon.
I think whatever we're in this course, say suppose like a Java did you say? Think that what I know?
Yeah. Yeah, I think so. I think so. Like as a software dev, probably. I believe so. There we go. So if I send a message, I'll close this. We'll close this.
So they can, did you miss that?
Accept. Oh. Okay. Did it wrong. Okay, yeah. Cool. So let me see if I can walk through this block of code. We don't really need to know all of it, but this particular block of code right here is the, yeah, is WebSocket example. So this is written in a fast API document, just like how we normally write our fast API stuff, where we do our imports at the top, our fast API, import fast API. We need to import WebSockets and also the disconnect method. Yeah. And just like how we define our, where is it? Our routes for handling HTTP requests, we need to handle our WebSocket routes as well. But the thing is, you don't need to set up more than one route, one for post, one for get, one for delete, and one for update. You just set up one route, and that one route is used for establishing a connection. You know? Yeah, just establishing a connection. So when you want to send a message, you connect to WS/dashboard in this case. And once you're able to connect to this route, then you can start sending messages, because we have code here that says accept any WebSocket that comes in. So any connection that comes in, just accept it. And accept means establish the connection. Yeah? This we don't really need to know about too much. What we need to understand is this part here, this part right here, so this while loop. You guys know about try catch? It's something that you'd have done in Java. You know about Java? In what? All right. Well, just know that in Python, try except is a block of code that you are running that you expect may return an error. And if it returns an error, you don't want the program to crash. You want it to be handled gracefully, so that instead of it crash, it actually does print something instead to show you that there was an error. Yeah? So there's a line of code somewhere here that Python is expecting could return an error, and if it returns an error, it would bring down the whole application. So instead of it bringing down the whole application, we catch the exception, or we catch the error, in this case, the WebSocket detection error, disconnect error, I mean. And if we detect that, then don't crash. Instead, just remove the WebSocket and then just print a message to say that the client disconnected. Yeah? So that part is not terribly important for how to create WebSockets. It's just a way to manage your code to make sure it's robust. Yeah? But what's important is this particular part here. You know, in C, you have your while one that is supposed to run forever. You have your while true here in Python. Yeah. That just says any message that comes in, just store it in a variable called text, and then you handle however you want that text to be handled after that. So in this case, I'm just saying print. Yeah. So I'm saying any message that comes in, just print it. Yeah. And the reason that is because I want to show you the speed at which you can send information from a client to a server. So on the left here now I have Postman. I've established my connection to the server using the WS or the WebSocket protocol instead of HTTP. And then I connect to, let me zoom in. I connect to my, how do you close this up? No? Jaja. Can I do this? Yes. Right. So I connect to the server using the route that I established here. WS dashboard, same as WS dashboard here. And once I establish my connection, I can just write messages. So I write a message up here, and as soon as I send that message, it should just print down here. Yeah, because I say as soon as I send that message, I just want to print it. So if I say hello, and I send it, it should just say hello. Yeah. If I say temp is 31, and I send it, it just says temp is 31. Yeah. And I don't really have a way right now to send a message back from the server, but it would essentially be the same thing where instead of saying receive text, I could probably put send text. Actually, can I just put that here? Let me see. Let me see. Can I just do WebSocket dot, how do you send? No? No suggestion? Text. Got it. Come again? If what? These is just a list of the message that I have sent. Oh, no, it's just Postman. Yeah. Yeah, WebSocket in Postman, yeah. Hold on, let me see. What do you mean?
So I guess supposed to send some temperature charge or receive temperature. So instead of me having to press send to see what the current like once you press send just keep on.
Oh, I'm not sure. I never use it like that. But yeah, you can create a WebSocket request by going here and choosing WebSocket. And you have MQTT as well. Yeah, so let me see if I can do a bidirectional test. Can I do a something like this? Text. Will this work? I don't know if that's the actual method. I can't have both of them on screen at the same time? That's wild. Oh. Oh, it broke. Because I wrote it wrong? Oh, connect. And then I send a message. Oh, I never awaited it. Alright, connect. Okay, yeah. So what I did a new line. So I get the text, I receive the text, and as soon as I receive the text, I store it in a variable and then print it. And then I just send back a message immediately and say, got it, and whatever the text was. And then say, yeah, I got it. You can send it back. So I was able to send a message here. I can say, hey. And then when I send hey, it sends back immediately, got it, and the message that I sent. So it's not to say that this is the only way that you can communicate. It is not a case that I can only send back a message if I get a message. It just very much depends on your scenario. So you can write this line of text right here, WebSocket.send text, anywhere in your code. And you can trigger it by whatever means you need to trigger it. If it's a case where your Python code is doing some kind of processing and it gets a message from somewhere else to say, oh, maybe a sensor reported that the front door was opened. When you Python get that code, it can create a message to the AC ESP to say, turn on the AC since somebody's home. Yeah? So it just sends a message to the ESP saying, turn on this pin. And then that pin will trigger a relay, and then that relay will connect to our AC and the AC turn on, or something like that. Yeah? So it's bidirectional. That line of code can be written anywhere in your Python code, as long as the WebSocket's connection is established already. And it will just send a message to whoever needs to get it.
Is this a radio connection?
What's that?
Is this a radio connection to all of that triggering the AC?
Yeah, for the AC, for the hardware part of it?
Yeah, like I'm going to just use, say, 5 volt, 3.3 volts from my AC. Trigger the AC.
Yeah. Yeah. That's how our smart plugs work, basically. It's just a relay.
So that means that you can make all of them?
Yeah, we could. But to do it as well as the big companies, I'm not sure. Well, not that. I'm talking about safety. Like, can you solder as well as a machine? Is that something you need to consider?
And maybe it's what SMD said.
Exactly, yeah. An SMD hard to solder by hand.
Some bulky thing.
Yeah. Yeah. Like, would you put stuff in a breadboard or a perf board and sell that as a final product? No. Exactly.
With that, the main is turn on the AC, so the door being turned on.
Mm-hmm.
it start moving.
Mm-hmm.
So with the app,
Mm-hmm.
is it a thing when you download the app, you have to make the connections in
Mm-hmm.
your system?
Yeah. So you'd have to.
Request them.
So you mean if you build it yourself?
No, you're not build it. So come pre-build the app, pre-build with
Mm-hmm.
all the button and everything. They can customize it.
Mm-hmm.
So you will build a system where there is a HTTP request.
Mm-hmm.
When you have to go into the app or set the request.
Mm-hmm. Yeah, so when you're building the app, you'd have to specify where the app is supposed to make the request to, how the request is supposed to look, where the server live, all that stuff. Yeah.
The server never works in that ways. Yeah, it have people set up. They don't want to turn on the LED.
Mm-hmm. Render is free, or it has a free tier rather. And with the free tier, after a certain amount of inactivity time, it goes down.
Yeah, but say it's down now.
Mm-hmm.
The request by what?
To turn it back on, you just make a request to it, and it will take some time to turn on, like a minute. Just make a request to it.
First request to the longest.
Yeah. Yeah. And after a minute, it will just turn back on. Yeah. Yeah. That's another thing that we also need to cover in class. I'm not going to do it today, but hosting, because that's relevant to your capstone. And essentially, Dr. Fontana wants me to make this course yeah? Tailored to capstone, yeah. So it's like a pre-capstone course, basically, even though we're having it while capstone going on in the second half of capstone, yeah. So yeah, I need to show how to do hosting as well. And he also asked me to do a session on hosting during the capstone session, so that's probably coming up as well. Hmm? Of course. Oh. Well, I mean, it gives you a place to start from. Yeah, it's better than nothing. Better than nothing. Well, yeah, any questions? Good with this? It makes sense? Mm-hmm. Got you. All right. Well, yeah, I would say, if anything, if there's any confusion, stick between. Actually, no, I can't say that. Just don't consider SOAP. That one is useless one. I would say consider between MQTT and REST, but getting MQTT set up is a whole process, and it's a lot of configuration. Where WebSockets might be easier. Yeah, it doesn't require all that much code. Because to be honest, this is just what? 1, 2, 3, 4, 5, 6 lines of code, essentially. I mean, there's a lot of padding, there's comments in it, and I don't consider the try-catch part, because the try-catch doesn't make this work. It just makes it so that if you disconnect, it don't crash. Yeah. But yeah. And yeah, I'll take your feedback into consideration in terms of the quiz. And if I can keep it the same way, I'll give you more time. Huh? I don't remember. Wait, hold on. You guys did 4 labs so far? Or is 3? 4? The one you just did lab 4?
Yes.
Oh, that's good. So I only have 2 more labs left. Okay. And then your project, which is just going to be a big lab. Mm-hmm. Hmm? You want what? Oh, it's due after exams. It usually is due after exams. Yeah. And again, make it so that you don't need hardware to do it. You can use your walkway if you want. If you're going to use walkway, it would be in your best interest to learn how to use walkway on your machine so you don't have problems. What if you have ESP, you don't need it?
I don't use my.
All right, that's fine. The reason why I make walkway available is because there are people that will say, oh, in order for me to do this course, I have to pay more money because I have to buy parts. I want to make it so that it's accessible to everybody. Well, it's not a guarantee, so I'll just make sure that I'm not barring anybody from doing it. Come again? I will post the bill of materials. and then it is up to you if you want to buy them.
A bill of materials.
Yeah, it's not very many things.
Well, this is supposed to do some stuff.
Yeah, it's like a couple resistors, 2 MOSFETs, a motion sensor, and a temperature sensor.
I mean, I don't know, so that's some other stuff.
Yeah, yeah.
And
And
make it say you can use outside of the class.
yeah, I mean, I did. It's universal. I made it very universal. As in, I have the PCB already designed, and I can give you the PCB, or not. I mean, sell you the PCB. I can sell you the PCB, and you just put your components on it. I never brought the PCB to class one time. No, we never show no. And I had it in my bag the other day, and I take it out. I don't know why. This project, I've been giving this project for the last 3 or 4 years, I think. Same project. Maybe 3 years. Or maybe this is the 3rd time I've given it. It's a smart home. A smart home hub. So like, it has 2 ports on it where you can connect 2 relays to it. So anything that can turn on or off by cutting or connecting power, you can power your stuff with that.
And so you want to provide, like bulk components and sell bulk them.
I could do that, yeah.
So that we have to work on the scale and jobs.
Right, yeah. That's studied in previous years. I buy the parts and the sell it to them. Where's the key card? Like this? Nope, not this.
Here it goes to the something.
Hold on.
You know, it's disappear from yeah, and go something like that. It only got Jesus. Everybody has a white man. Nothing else fun with it.
ECSE. I'm supposed to have something can show. I don't remember where it's saved. Jaja. Here it is.
You can send it down and things, please. I want voice note.
This. Yeah, here we go. There you go. How do I zoom out and then tilt? Here we go. So this is what it would look like. Oh. Let me turn on this. This ray tracing. It looks pretty. So, oh wait, is this an old design? Did I not update this? This is not supposed to say light. Like this label say light and this one say fan. But it's not. It don't matter exactly. That's why I need to change the label. So you have your power in, and this, yeah, barrel jack. It can take whatever voltage you put on it, because this the ESP underneath the ESP is a buck. Like on the PCB, there's a buck that's connected between this and this. You can cut on the voltage. Oh, it is keycard, but it's not under the PCB. It's not under the PC. It's under the ESP. I don't know if I take off the ESP. I don't know if you're able to see it. Oh, you can't really see it. The printer. It kind of small, yeah. Oh, I have it in my bag.
Or is that SMD?
I made it SMD. It is a through-hole component, but I made it so that you can just solder it directly to the board. I'll get the next one.
But is that this?
That's the buck. It's one of the expensive ones, so it should be good. I think it's a good book. It should be. Right, exactly. I bought it because it's small. Yeah, I get what you're saying. Yeah. Right, yeah. I got it quite small. Right, yeah. I know. But yeah. Yeah, man, it's good.
But this guy, you can adjust.
Yeah, you can adjust. That will adjust. Tap the dial. Yeah. So the way I have it set up is this jumper right here. If you put a jumper on it, then the power from this goes to the buck, and then you can power the ESP. But if you leave this off, this will only power these, and then you have to power your ESP through USB instead. This, by default, when it opens, none of the power goes to the buck. If the power don't go to the buck, then it don't power the ESP. But if you put a jumper on this, so like if you solder them together, the power from this will go to the buck and then power the ESP. Yeah, this is an open line by default. So you'd have to join it to get power from this to the buck to the ESP. Yeah. But so it's optional. So the buck itself is optional. You don't need the buck. Yeah. Yeah. You can power this through USB, and then these get the power through this. So essentially, can I get back proper? How you reset this thing? Judge. Guys, I'm failing. What, these? Those are where you connect your wires. Screw terminal. Yeah. So let me see. These two MOSFETs get triggered by the pins on the ESP. So it acts like a relay. ILZ, I think. Or RI. Remember, something like that. A logic level MOSFET, right? Yeah. So the power goes to these, and they're broken or set by the MOSFETs. So if you have this, can, for example, take 12 volts. You put 12 volts on this, this will determine whether or not this get 12 volts or not. Yeah? And then these are controlled by the ESP. So you write code to say whether or not the voltage is supposed to be applied to the MOSFET. And if it, of the MOSFETs? For this voltage? I don't know. I don't know about MOSFETs. Honestly, I don't know.
Yeah, no, not about the MOSFET, but can I AC kind of a fan to that?
So ideally, you put a relay here, and then you connect the relay to the fan. So no, you wouldn't plug a fan into this. Because this is, this just triggers a relay.
It's just a trigger.
Yeah, just a trigger. So essentially, to make this work, you could just put an LED right here. So, and if the LED turn on, then we know say this trigger. Yeah. So as long as you can show me that there's voltage here, then we're good. Yeah. And like I said, it's just 2 ports. So it's just a fan and a light, basically. And then here is where you put your temperature sensor on this. Yeah. So your temperature sensor goes on this. It has the 3 pins. And then your motion sensor goes on this. Huh? Yeah, IR motion, the PIR. Yeah, so we're detecting presence and temperature. Do what? Include what? Oh. Yeah, it's a whole thing. Well, yeah, it's essentially what you're going to be doing. If anything, I'll see if I can remember to carry. I have one built out already. I'll bring it tomorrow and show you in class. But yeah.
Tomorrow. I think this room we use tomorrow.
For what?
Research day.
So nobody ever tell me.
What's that? Research day tomorrow. But the whole of them is. Okay.
Really?
Mm-hmm. Them no respect you.
They don't respect me.
No
They don't respect me. It's crazy. All right, well, I'll find out from whoever I need to find out from. Yeah. All right, cool.
Yeah, really.
I don't have any relays now. If you want to know what I have, go on stores.philiplogan.com. Yeah, and I will show you everything. Yeah, we live in a year. We live in 2026, you know. We have AI, so I don't have to do any work. I just tell AI what to do, and it will do it. .philiplogan.com.
By the way.
Hmm?
Oh, it's okay. Story. You see how wood, water, yeah, just set up
No.
vehicle.
But one of the options is the whole kit for the project. So it is something I thought of too. But I also allow you to choose what and what you want. Because not everybody, for example, some people already have resistors, some people already have MOSFET, some people don't want the buck, for example. Yeah. No. Huh? No. He asked me the same question. Yeah. Let me tell you, the reason I don't put images on it, let me end this. The reason I don't put any images on this is